Discuss this very amazing projectile problem. Let's read it first and then try and solve it. Okay. And I'm going to give you something very insightful. So stay with this video through the end. All right. So you have a cricket ball which is thrown across a field at heights h1 and h2 from the point of projection at times t1 and t2. So after time t1, the height is h1, and after time t2, the height is h2. Okay. The ball is caught by the fielder at the same height as that of projection. So the diagram actually is this, right? So you have a fielder here who catches it at the same height from where it is thrown. What you have to calculate using this data is the total time of flight of this journey, right? Which is a very standard question in projectile, except for the fact that in this question, if you see, the expressions are very tricky because the only known variables are h1, h2, t1 and t2, right? So the whole focus of the question is on y-axis, if you notice, right? Now let me just try and solve it, okay? Because I know the height, so obviously I will use the y-axis motion. So I will use s is equal to ut plus half at square. So when I want to use that, what happens is I will use h1 is equal to uyt, which I don't know what is the velocity of projection in y-axis. T1 I know, minus half g t1 square. This is one equation. The second equation is h2 is equal to uy t2 minus half g t2 square, right? 2. If you notice, right, this is one equation, and what are we supposed to calculate? We are supposed to calculate time of flight. Now the time of flight is calculated by using this particular expression, which is 2 uy by g, right? Which is uy is u sine theta actually, right? So if you notice all the expressions that you see in front of you, right? Which if you notice this one, if you notice this one, this one, this one, none of the expression has any mention of gravity. There is no mention of gravity. But if you notice uy, even uy is not known to us. So question basically is that you have to convert this expression uy by g into these expressions, right? One of these, obviously, not very sure. How do you do that, right? So that's a dilemma. Now, the way to solve such a question is elimination of variable, right? We want to express uy upon g like this, a, b, c, d, right? And we have two equations. So what you do in these is you solve these two, okay? You have two variables. When I say variable, actually, I mean you have g. So I can rewrite this expression in one form, which is I can calculate the value of uy using this expression, right? So uy I can obtain using this. The second thing I can do is I can calculate g by these two equations. Let me give an example of what I'm trying to do here. If you see this, I can write uyt1, I'm using this particular one, is equal to h1 plus half g t1 square, right? And similarly, I can write uy t2 is equal to h2 plus half g t2 square, right? So you have 1 and 2 equations, right? And then I can do one thing. I can bring down the t1 here, and I can write it as uy is equal to h1 t1 plus half g t1, right? And similarly, I can write uy from the second equation as h2 upon t2 plus half g2 square by, right? So this will become cancel and this will become t2. So I have two equations. I can eliminate these hy by saying 1 is equal to 2. So h1 t1 plus half G T1 is equal to H2 by T2 plus half G T2, right? So this is the equation. Like, what do I calculate using this, right? It's not T squared, it is T2. I can calculate G from this. How do I do that? I will bring this expression here, and so this will become H1 T1 minus H2 T2 is equal to half G T2 minus half G T1. Okay, so this will become H1 T2 minus H2 T1 upon T1 T2 is equal to G by 2, and this will become T2 minus T1, right? And then I can write G is equal to 2 H1 T2 minus H2 T1 upon, and I can collect these two. This will become T1 T2, and this will become my expression which I've taken is T2 minus T1. So I have got G. I will substitute this value of G here, and I will find Uy also, right? Once you find the value of G and you're able to find the value of Uy, okay, by substituting the value of G in this or this, you can get a Uy also. Once you get it, once you get G as this and Uy also, what you do is you put the values of Uy and G here, right? You see there is no G in any of these expressions, very importantly, right? So put the values here and you will get the answer. So if you do the calculation of Uy and G and divide them, A is going to be your answer. So one of the things you have to learn about solving problems is, when I saw this question of projectile, what struck me was, where is the gravity mentioned? There is no mention of gravity at all. And that was bothering, right? So I had already concluded that whatever equations we are given, right, we will have to eliminate G from them. And then I noticed also that time of flight also needs a Uy. Again, I did not have a Uy in the question. So these two equations gave me Uy also. With the method I told you, you've calculated G. Put it back in any one of these and you will get the value of Uy also. Then put Uy here and G here and your answer will come. So a lot of questions can be solved from the answer itself. Have a close look at the question and then try and solve the question instead of getting struck, or getting baffled by the complexity of the answers. They look very, difficult to understand. But I hope you like this video immensely. Subscribe to it. Don't forget to subscribe to my YouTube channel. You will see some amazing exam-like questions, right? And also subscribe to my blog. Okay, I keep on writing some blogs and good articles on what are top tips for examination, explanation of complex topics on mechanics, electromagnetic induction, electrostatics. So you will see a lot of exam tips and exam questions, on the blog and my YouTube channel. Follow it and also spread it so that more people can benefit from you. And my number is available. You can reach out to me if you need any help in physics, and we can discuss as to how I can, contribute to your success in the upcoming examination. Thank you very much, and have a good day.